So try these questions in your copy before looking at the solutions. Question 3, find the value of x. Anytime we have an unknown variable, our formula will be missing something, but we have enough information to simplify down quite easily. So we just need to know here the area of a triangle. Half the base by the perpendicular height. So we have half the base, which is 17, by the height, which is x, is equal to the area, which is 51. If you multiply by 2, you get 17x is equal to 102. And then dividing 102 by 17, 6 17s are 102. So x is equal to 6 millimeters. B, well, if it's a square, we can say that they're both x, so we still only have one unknown. So we're going to say x times x, which is equal to x squared, is equal to the area, which is 361. And you should know at this point that the square root of 361 is 19, and we're dealing in centimeters. Question 4, find the radius of a circle with circumference of 24 pi. So 24 pi is our circumference. So what can we say about the circumference of a circle is equal to 2 pi or. There's only one unknown, or, and this is equal to 24 pi. So you can divide across by 2 pi to leave yourself with or. So we divide 24 pi by 2 pi, we get or is equal to 12. And that's in centimeters. So try and just mark down what you're going to do next. The area, in this case, in B, area is equal to pi r squared. So just write that to start. Area is pi r squared. And what are we given about this pi r squared? It's equal to 16 pi. Just write down 16 pi. The only unknown we have is r. So we can say r squared is 16. We already have r squared is 16, but if you want to write it out again to keep it neat, now r could be plus or minus 4 here, but we can't have a negative distance. So r is equal to 4 centimeters in 4b. We have 5, 6, and going across a few more there. So we'll do 5 over here first. So taking pi, we're told, is 3.14. Find in each case the radius of a circle. C is equal to 50.24. So the circumference is equal to 2 pi r, which is equal to 50.24. So you can see here the only unknown we have is the radius. So writing down in your copies or exams what you would type into your calculator, the 2 and the pi, we have to divide by them, 50.24. So on the fraction button on your calculator on the bottom, you're going to have 2 pi. You can use the pi symbol on your calculator, where you can put 3.14, which we're told to take, or 3.142 for more accuracy, into your calculator. And 50.24 divided by 6.28 is going to give us exactly 8. And we were dealing in meters. That's why we were asked around to 3.14, because it works to an exact number here in this case for A. B, area is equal to this number. Area is pi r squared. The only unknown is r, but we're told that the answer is 1133.54 in meters. If you want to write that down. So we're just dividing by pi and getting the square root of it. So r squared is equal to 1133.54 divided by pi. 3.14 must go in on your calculator. R squared does go in, 361. We've seen this already. R is equal to 19 meters for 5b. For 6, maybe we'll put some work onto the diagram itself. So the path, the area of the region shaded red, which is the outside, correct to 1 decimal place. Just write that down, 1 decimal place here. And all curves are sectors of circles, which will be in part B here. So this path here is 1.5 wide. 1.5, 1.5. So if we continue this line across, it's 1.5, 1.5 is 3, so that leaves us with 18 minus 3, 15 going that way and going this way. We've also got to take away 3 from 16. So the whole thing, which is 18 by 16, if we take away the area of the inside, 13 by 15, we will be left with our answer here, the outside bit, and 18/16 is 288, and if we take away 13/15, which are 195, we are going to get 93, and we are asked for in correct one decimal place. Well, this is exact 93 meters squared. Next one here. Okay, what have we got? So we have a rugby ball inside a square here, so let's have a look here. This is a quarter of a circle with a bit to the left attached on. So this is a quarter of a circle, so we can get the area of that whole thing. And if we take that area away from 225, this 15 by 15 is our total. So we need the area of these bits in here. I'll do squiggly lines in here. So we can get the area of that quarter of a circle, take it away from 225, we'll have what this area is in here. So let's have a look. The quarter of a circle, which is pi or squared divided by 4, pi from the calculator in this case, that's equal to 176.7375. I'll take 4. So that's this guy, this shaded guy in here is 176. The whole thing is 225. So if we take 176 away from 225, we're going to get 48 and a bit left over. So 48.2625 is going to be this bit in here. And if we get the two of them, so if we get that one and add them together, take it away from 225, we'll get what's left in the middle. So we have 225 minus twice 48.2625. So that's going to give 128.475. 128.475. And it was one decimal. It's giving me now rounded off probably differently than the question wanted, but 128.5 in this case, and that's centimeters squared. Okay, we have up to question 9 in this video. So let's look at 7. If you've ever ordered pizza, the box is always a little bit wider than the pizza, or the pizza wouldn't fit in. And in this case, to ensure that the pizza fits properly, the sides of the box are 5 cm longer than the diameter of a pizza. So I can actually do that. See here in the box, there's a bit of room to spare in here and in here. Not quite visible on my diagram, but you get the idea. So there's a little bit of room to spare. We bring this down in between the pizza and the edge of the box. So what are we given here? 8 slice pizza. The area of the pizza, the area of the top of the box is 784. Well, because it's a circle, it has to be symmetrical, so it has to be a square box. You've never gotten a rectangular pizza box. So the square root of 784 will give us the length of one of the sides. You should probably know that that's 28 at this point of your mathematical careers. So that's the length of one edge of the box. We're asked the radius of the pizza. Okay, well, if from here to here, we have the whole width of the box. So the whole width of the box is 28 and it's 5 cm longer. So this has to be 23. So that's the diameter of the pizza. So the radius is 11.5. 2 of them is 23. And then the area of one slice, well, the area of one slice is pi r squared. There were 8 of them over 8. Do they tell us anything about pi? 3.14. So 3.14 by 28 squared, which we know is 784, divided by 8 will give me the area of one slice of pizza. And I haven't taken the radius of the pizza. Hang on. I've taken the width of the box just to annoy it. Let's put the radius in here, obviously. Pi r squared. And 3.14 by 11.5 squared divided by 8 is 51.941. And it didn't say anything about rounding off. We'll leave it at 3 decimals, and that would be in centimeters squared. Okay, question 8. Sometimes these diagrams can look a bit trickier than they are. So what are we told here? It shows a rectangle. The sides are divided into 6 equal parts. Some of the endpoints of these parts are joined by line segments. Find the percentage of the area that is shaded. Okay, what about if we can take that box off and that box off, and we connect, make this a triangle too, and actually we could number them now. We've got similar areas here. So if we say that each area of this size is 1, we should be able to create a ratio here. So this is a half, this is a half. And how many? Well, you can see that in the 2 big triangles here along here, there are 3, and they're about the same size, so they're about 1.5 each. So the shaded is equal to 1 plus 1.5, 2.5, and 1.5 is 4. And the non-shaded is equal to just to 1.5 and a half, so just 2. So the total is 6, which we had said we were told at the beginning. So the percentage that is shaded is 4 over 6, which is 2/3 times 100, 66 and 2/3%. And then question 9, the start of which is in this video, the second part of which will be in the next one. An area of square tile with a quarter circle outlined on it, shaded in blue, is shown. Find the area of the shaded region correct to 2 decimal places. Okay, so again, similar to a previous question, we have a quarter of a circle and we have a square. So the square is 45 by 45. So we'll probably do this in one step. And if we take away the area of a quarter circle, which is pi by 45 squared over 4, that should give us this shaded bit here. And we'll do it in 2 parts just to be super careful, because we'd always have time in the exam to do it in 2 parts. So we're going to get 2025, and these measurements are in millimeters here. The next part of the question starts dealing in centimeters. Minus 1589.625, and that's going to give me 435.375, and that's in millimeters squared. So going back to centimeters squared, if we think about it, 10 millimeters by 10 millimeters is equal to 100 millimeters squared, and 10 millimeters by 10 millimeters is also 1 cm by 1 cm, which is 1 cm squared. So to go from millimeters back to centimeters, I have to divide by 100. So this is going to be 4.35375 centimeters squared. We could probably just round that off to 4.35 centimeters squared in the shaded part. So go on to area volume 3 and continue with this question.